Today, we will take a look into how can we solve trigonometric functions, but today we're going to be looking into a more challenging problem here. But one thing to keep in mind is that when it comes to solving trigonometric functions, our objective is to find out the value for theta. Because once we know the value for theta, then that's when we can claim that we have solved a solution here. Right? We have find the solution of a function. So let's get started here. So let's take into some things to remember here. Remember that when you're solving for a sine, whenever you have a sine or cosine function and you're trying to solve it, if you do it through the calculator, it's only going to give you one solution. So what you also have to keep in mind is that we have to find out if there's also a second solution. And remember that if we have a sine function, in order to find out the second solution, we're going to have 180 minus the first solution. And when it comes to the cosine, it's going to be 360 minus the first solution. So keep that in mind. So let's take a look into a problem that maybe we have seen before, which is here what we have is that, well, we want to find out the value for theta because we want to solve the following function. We want to know what this value is right here. So what do? Well, just like it was explained on the previous video here, the first thing that you want to do is to isolate the function. So in order to do that, we're going to subtract 1 here. It cancels out. So now I have sine of theta equals 1 minus 1. Well, that's 0. Okay, perfect. And remember that if you want to cancel out the sine now, because notice that if we do cancel out the sine function, if somehow we were able to cancel out the sine function, we're going to get theta by itself. And for us to cancel out that sine function, what we have to do is we got to multiply by the inverse function. This was explained in lesson 41. So let's multiply by the inverse function. Because once we do that, then the sines cancel, and now you get the theta by itself. So this is saying that theta is equal to the sine of inverse of 0. And this, it might look difficult, but this is something that you can plug in the calculator. So let's keep that in mind. So let's turn it on. But before we do any work, we need to make sure that our calculator is in degree mode. So we're going to go to mode, and we're going to hit degree, because notice that right now it's in radian. So we want to go in degree mode. So we go here, make a right, you press enter. So now it's in degree mode. So let's get out of the screen. To get out is second, quit. So now let's actually figure out what is sine of inverse of 0. So regularly, you just have sine. It's a little bit small here, but if we press second, notice that on top of sine, you see sine of -1, which is an inverse. That's exactly what we want. So sine of inverse of 0. So press that out. So here we have that theta is equal to 0. So this is something that we have seen. So this is one solution, but remember that we have to check for second solutions. So notice that what we solved here was a sine function. And in order for us to check the second solution for sine, so the second solution here, we're going to be doing 180 degrees minus the first solution. But the first solution, 0 degrees, the first solution here was 0 degrees. So 180 minus 0, so that's 180 degrees. All right, perfect. So we got the first solution, we got the second solution. All we got to do now is just put them in a complete sentence. So our solutions are 0 degrees and 180 degrees. So this is something that we have seen in lesson 41, but we want to take a look into something that is more complicated. So, and you can see that in example B now here. So what's the difference between example A and example B? It might look the same, except for the sine and the cosine. But notice that in example B, now we actually have second exponents here. So this, once we have a second exponent, things change a little. But let's see, they're not that bad. You just gotta be super organized. So what we have here is the following. We have cosine square of theta plus 3 equals to 4. So what we have to do here is still the same. You want to isolate the whole cosine square of theta. So in order for us to do that, let's subtract 3. So now we're going to have cosine square of theta equals, well, 4 minus 3 is 1. So that's perfect. So now this is where it gets different because you might like to work with this cosine square of theta, but this function, you can rewrite it as this. Cosine theta square, the whole thing is square. Now, I will prefer to write it into this way. Why? Because you can see now that because the cosine is raised to the second exponent, you want to get the cosine by itself. And to get the cosine by itself, you need to cancel out the second exponent. And we saw in previous lessons that if you want to cancel out the second exponent, you can take out the square root on both sides. So this cancels out with this. And now we have that cosine of theta is equals to the square root of 1, which is 1. So now notice that there's no second exponent. Now we just have the cosine. So if we want to get the theta by itself, we're going to multiply by the inverse. So the inverse of cosine is a cosine inverse. We're going to multiply that left and right. If we do that, this cancels out. So now we have theta by itself. So theta equals to the cosine negative 1 of 1. So now notice that this may look tedious, but notice that this is just nothing more than calculator work. So we're going to go to our calculator, and now we're going to press cosine inverse. So we're going to press second, and on top of cosine, you can see cosine inverse. So cosine inverse of 1. So we see that theta is equals to 0 degrees. So this is our first solution. The first solution is 0 degrees, but notice that we have to check the second solution. So now if we want to check the second solution, we got to remember that we're talking about a cosine function here. So if we come back here, notice that for us to check the second solution, when it comes to cosine, is 360 degrees minus the first solution. So the second solution is going to be 360 degrees minus the first solution, but we know that the first solution is 0 degrees. We got it. And then here, well, 360 degrees minus 0 degrees is 360 degrees. We got the first solution. We have a second solution. So what do we do now? We just got to write down our final answer. Because the answer for this problem, or the solution, if we say, the solution is going to be 0 degrees and 360 degrees. So notice that example B, it's almost the same as example A, but the only difference is right here with the second exponent. In order for us to cancel out the second exponent, we got to take the square root. Now, let's take a look into our last problem here. And notice that this problem looks a little bit difficult here, but it's fine. Now, notice that what we have to do here, there's different ways to approach this problem. One way that I will suggest for you to do is to just rewrite the function. Because here, notice that cosine square of 32, we can rewrite this of cosine 32, the whole thing, raised to the second exponent. plus the sine x, all to the second exponent, and 1. This is just notation. You can leave it as the original problem. There's nothing wrong with it, but it's preferable for you to put the second exponent outside because it becomes a little more clear. But let's see, what exactly are we trying to find here? We want to know what the value of x here, right here, because this is the only variable that is unknown. So, is there anything that we can find the value of? Well, notice here, we have the cosine of 32 degrees. That's something that we can find in the calculator. So let's see what that is. We're going to get the cosine of 32 degrees. And according to our calculator, the cosine of 32 degrees, it's 0.84, 80. Now, I'm just going to round it to 4 decimal places. So notice that all we're doing here, we're just rewriting it we're just making it more simple. But now we know that the sine of 32 is 0.8480. This decimal, we got to raise it to a second exponent. So we're going to clear it. So now we're going to press 0.84. Well, I'm sorry. Let's put a parenthesis. 0.8480. Close parenthesis. Let's raise it to a second exponent. So that means that the first term, it's going to be 0.71, 91.04 plus still the sine of x to the second exponent. This looks a little bit like example B, because what you want to do now is leave this whole term by itself. And to leave the second term by itself, we got to eliminate the first one. So what we can do here is we can subtract 0.71, 91.04 to both sides. 71, 91.04. Let me rewrite that. Put both sides. So now what we have here, let me just extend the page. All right, perfect. So now we have here, we have that the sine of x to the second exponent is equal to, well, let's see what we can do with this. So let's figure out what that is. 1 minus 0.7191.04. Oops, forgot that. That's 0.4. So now the right side is 0.28. 0.28, 0.8, 96. Notice that this is looking like example 2. So if we want to leave the sign by itself, we got to eliminate that second exponent. And we know that we can do that by taking the square root to both sides. Now this cancels out with the square. So now we have the sine of x equals to the square root of 21.08, 96. So let's take the square root of that. Square root of 0.28, 08, 96. If we do this in the calculator, we have 0.52, 99. Let's just round it to 4 decimal places. You don't want to write the whole thing. We want to leave the x by itself. So let's multiply the inverse to both sides. This way, the sign will cancel out. We have x equals sine of inverse 0.5299. The right side, we can find it in the calculator. So let's place clear. Now we press second, sine 0.5299. Press clear, and there's our answer here. It says that x is equal to 31 0.998. Let's just round it to the nearest degree. So if we're going to round this to the nearest degree, we're just going to say that this is 32 degrees. We have our first answer here. So this is the first solution, and we're good. So now we have to find the second solution. But notice here that we're talking about a sine function. And if we remember, if we go all the way to the top here, when it comes to the sine function, to figure out the second solution is 180 minus the first. We have our second solution here. So now when it comes to the second solution, it's going to be 180 minus the first solution, but we know that the first solution is 32 degrees. Figure out what that is in the calculator. 180 minus 32. That gives us an answer of 148 degrees. All we got to do now is to write down our conclusion. That means that the solution is 32 degrees and also 148 degrees. And this is your final answer. Notice that the problems become a little more tedious. Yes, it's a little bit longer than maybe what you're used to, or at least the examples that we saw in the previous lesson. But notice that all we're doing here, we're just repeating the same steps as lesson 41, but because there are more terms involved and because there are second exponents, then the process it's a little more tedious, or at least requires more of a calculation process. So here is your entrance ticket. Solve the following function. And just to give you a hint, you can rewrite this function as the cosine of 90 degrees, all to the second exponent, plus the sine of theta to the second exponent equals to 1. You can work the example either this way or this way.